Hi, this is the flipped instructional session for Earth Science Semester B, and today we're going to be talking about Lesson 1.13, Factors that Affect the Climate, and I am Mrs. Fessel. If you are taking notes using the note-taking guide, these are the notes we'll be taking today. From Lesson 13, we will be analyzing how the following factors affect climate: the latitude, proximity or closeness to bodies of water, ocean currents, specifically how the Gulf Stream affects the climate of Northern Europe, the land elevation, altitude, and then we will talk about how mountain ranges and other major geographical features influence climate patterns. Just as a review from earlier lessons, what's the difference? Weather is the day-to-day conditions of an area. The temperature, the wind direction and speed, air pressure, relative humidity, precipitation, things like that. Whatever you see when you look outside your window at that moment. Climate is the average weather in a location over a long period of time. So even though it might be sunny in a place one day, that place's climate might generally be cloudy. So it's the long-term average of the weather, and that's what we're going to be talking about today. So the first thing that affects the climate of an area is the latitude. So the Earth is a sphere, and radiation from the sun heats the Earth's surface unevenly. The middle of the Earth, near the equator, if you see 0 degrees here, where the latitude is low, is generally warmer than places like near the North and South Pole, where the latitude is high. If you see here, sunlight is directly overhead at the equator, warming this area more. At the North and South Pole, the angle of the incoming sunlight is low. The sun does not appear directly overhead, and that creates a colder climate. So a warmer climate has a lower latitude and are near the equator. Colder climates are at a higher latitude near the poles, because again, that low angle of the incoming sunlight. The next thing that affects the climate of the area is proximity to bodies of water. There are two big things that bodies of water create. The first thing is differences in air temperature over the sea and the land create a breeze or a wind. If you've ever been at the seashore, you might have noticed it's usually windy. Additionally, ocean winds can carry a great deal of moisture with them and can bring rain or fog onto land. If you look at places, for example, like Seattle, Washington, it is very rainy and foggy there because the winds from the ocean carry all of the moisture into the land. So the second thing is, as I was saying, the breeze. The land warms up faster than the water during the day. And as we've talked about in a lot of our lessons, warm things rise, as you can see right here. And that creates a breeze as the cool air rushes in from above the ocean to take the place of the warm air. The opposite happens at night. The land cools off very quickly. If you've ever been to the seashore, you know that the sand is really hot during the day, and if you have ever walked on it at night, it's very cold at night. So the land cools off much quicker than the sea. So that creates cool air dropping over the land and warm air rising over the ocean, because the ocean holds its heat better during the night. The ocean is more of a consistent temperature. So a convection current moves in the reverse direction from the land to the sea. So this is why at the seashore it is often very breezy. Here we can have one more example that during the day, the warm air rises over the land, drops during the sea, creating a sea breeze, whereas the opposite happens at in night. The sea is warmer, so the warm air rises above the sea and drops over the land, creating a cool land breeze. Next, we have ocean currents. Currents can warm or cool the air over them. The wind can carry that air into neighboring land areas. So the warm arrows are showing warm ocean currents and creating a warm climate. The blue arrows are showing a cool ocean current, creating a cool climate. A great example of this is if you look at Maine right here compared to England right here. So Maine gets these cold currents coming down from the Labrador. That creates very cold climate here in northern Maine. The opposite happens over here in England. The warm Gulf Stream brings up warm air, creating a generally warmer climate in England. So each time you see a cold arrow, it's usually going to be creating a colder climate. A warm arrow will be creating a warmer climate. As I mentioned, one of the most famous examples of this is the Gulf Stream. The British Isles in Western Europe have a much warmer climate than other areas at the same latitude, such as Labrador, Canada, right here. The Gulf Stream brings this warm water to the British Isles and helps keep the climate warmer than it otherwise would be. Here in this heat image, you can see these warm areas of water are moving up towards England to warm the climate. Again, just another picture of the Great Ocean Conveyor Belt that brings warm or cool air to different places around the Earth. So next is altitude, not to be confused with latitude. Altitude is the land elevation. Seattle, for example, is at a lower altitude than the mountains. At a higher altitude, up here, the air is less dense. When air loses density, it is also loses heat. So this is why as you go up into the mountains at a higher altitude, the land has a higher elevation, it is cooler versus down at a lower altitude, the air is much warmer because there are a lot more molecules. And finally, we have geographic features such as mountain ranges. One of the biggest things that a mountain range does is it blocks the wind. This is a great example of this is in California. As moisture-filled air hits the mountains on the wind-facing side, which is called windward, there's a lot of rain and snow on that side because the air is forced to rise, cool, and releases its moisture. As that wind keeps blowing across the mountain range, on the opposite side of the mountain range, over here, the leeward side, all or most of the moisture has been lost. So the leeward side of the mountain is usually dry and cool, where the windward side, or the side facing the wind, is usually moist and will be getting a lot of precipitation. Here's what I was talking about, that as the wind comes off the Pacific Ocean, it rains over the smaller coast range, but it doesn't lose all its moisture. It keeps blowing, hits the larger Cascade Range, and the west side of the Cascade, or the windward side, gets a lot of moisture, wind and rain, where the east side of this mountain range is quite dry. So again, this is the worksheet that we just went over from the note-taking guide, Factors that Affect Climate. I hope to see you for the flipped follow-up, and I hope you have a great day. Thank you. Bye.